Hello everybody, this is our final project. We modeled the Tesla Model 90X. It was modeled by Daniel Brockenbrough Johnson, Joanna Kwansoon, and Ryan Lee. The order of business today is we'll start with the part allocation, personal parts of complexity and interest, and finish with a conclusion. The parts were assigned by giving the wheel, trunk, steering wheel, front car seat, undercarriage, and back seat to Daniel. The hubcap, wing doors, mirrors, dashboard, tail lights, license plate to Joanna, and the front doors, the hood, headlights, Tesla decal, the door handle, and the car main body to Ryan. So my part of interest will be the steering wheel. The following slides will talk about the design process and complexity of making this part. Here's the final designed steering wheel. So the first step was to create a profile sketch, which was followed by creating a guide curve. This was then used with the sweep tool to create this profile here in GSD. The following step was to create the mid-wheel feature, which was created in Sketcher on the YZ plane, then extruded with mirrored extent, and followed by using the fill tool, which will be shown in the next step. The fill tool was used to fill in the prior sketch, and on top of this, the horn was created in Sketcher, which was also filled in with the fill tool. For this complex shape here, the process was to create an offset plane from the YZ, create the respective profile sketch here, then use the multi-section surface tool for continue to generate this shape. Then this was filled. The final step was to close all of the filled surfaces, which would generate the solid part shown here.
Hi everyone, I'm here to go over how I did the wing doors for the Tesla Model X rendering. And you can see I also illustrated the internals over here, and this will be the externals of the door. We're going to be reviewing the externals of the door and generating that part. The internals were generated in the same manner. So in order to create the final elements seen here with all of the construction elements, I started with coordinate points. Coordinate points were the easiest method of building this part. So I created simple points at specific locations along the door, and using the line and spline elements as well as coordinate points function, I was able to create a lot of different geometric elements to create the shape of the door. Once that was done, I used the fill command to fill in the surfaces that I had defined with my lines and spline elements. And once that was done, I was able to take these multiple surfaces and join them to create one part. Once that was done, I exited the GSD system and went into part design and applied a thickness to that surface. The thickness really just depended on what was required for the part, and I think for this part it was measured about 1 millimeter thickness, so I applied a general thickness to the door. Next, I was responsible for getting rid of that window blockage here, which would basically be the similar process used before. I went on the GSD and I created this set of point definitions using lines and splines again to create a curvature for the window. Once that was done, I was able to join the surface and then project that joined window curvature onto a separate plane. The plane in this instance, based on how I oriented my door in order to render it, would have been the ZX plane, and I was able to project this onto the ZX plane and then go into part design and create a pocket. And that pocket would have created this entire element. Next, I went and created 3 points on the top of the door, and then using those 3 points, drew on that surface to create this square here that I used to create the hinge of the door. That surface was then swept with this simple definition shown here, which was drawn in our XZ plane. And that simple surface was drawn using the spline tool. The hook was swept out of there. And then lastly, in order to create the last hook shown at the back of the door, I created successive planes that were offset from the original part. And angling those planes was pretty important given that the door was curved downwards. I was able to angle the planes so that once this part was mirrored on the right plane, it would be mirrored in order to connect to the door without creating any extra work of having to cut off surfaces. And a result of adding up together all these elements, I was able to create the final part, which was the winged door, and you can see the external geometries here, and then some of the internals would have been the door rest as well as the door handle.
So for me, I would like to discuss two parts. Both of them are, for me at least, really complex. The first one will be the car frame, then I'll talk about the front door, which will be split into two subsections, the exterior and the interior itself. So for the front door, I use for the car frame, actually, not the front door, I used the door frame of the front door to sketch the B-pillar. And then from then, I created the sloping roof line that connects to the B-pillar as well. This is done from like sketch tools with profile and spline. Then I created the rear cargo area from the sloping roof line. This is done by creating an offset plane and then constructing the rear cargo area from the rear with profile and spline tools, and then padding the length of the trunk from the C-pillar onwards. So this is the front cargo area, or for an ICE car, the engine bay. This is completed by sketching and then padding from the side, and then creating the profile of the front by using fillet tools. So this is, I will talk about the complexity of the car frame later on in the completed slide. For this, I'll start talking about the external door itself. So this is sketched first before the frame does, but this is a much simpler design. It is done by a sketch from the rear with profile and spline tools, and then it is padded along the length of the front door dimensions. Afterwards, I did the hinge. This is sketched from top down with profile and spline tools, and then I used the hole command to create the hole for the hinge where this area is going to be connected to the frame of the car itself. So this is going to be the other part of the door, which both of them combined together will be the whole door itself. This internal part is completed by sketching the profile with respect to the profile of the external door itself, so that the curves match up, and then afterwards padding the length of the door itself. So the complexity is where the contour of the internals are. As you can see, the curved part with the door handle, the pocket where the storage would be. These are done by, for the pocket itself, the pocket command after sketching, and then for the handle, it was sketching and then padding. And then both of these are pocketed and filleted to match the contour that was measured. So these are the final products of the car frame and the door. The external part is shown for the door, not the internals. Unfortunately, I couldn't get a screen grab of both. The major complexity here was that I should have used GSD tools instead of using part design from the start, especially for the car frame, but given that I wasn't too comfortable with GSD, this was what I did, and the results, while they are adequate, at least not perfectly, it could be done much better with GSD, and creating a lot of these surfaces were much more difficult in part design than in GSD itself.
So in conclusion, some of the lessons learned would have been the curve geometries definitely required much more than part design. It required a lot of GSD and a lot of wireframe elements, and they were simply very complex to create. Secondly, part dimensioning for the small products proved really difficult because of the small surfaces we were working with, primarily in millimeters, sometimes dimensions ending up in 0.5 millimeter or 1.5 millimeters. CATIA had a lot of problems rendering those shapes accurately, as well as being able to pad and thicken those shapes accordingly. Because of the curved surfaces, some of the things that we also learned was that parts often require several iterations, several different shaped copies of different parts, of variations of different parts in order to piece together how to correctly build an element, and that sometimes took away a lot from time spent on rendering. Some of the improvements that we would definitely recommend moving on would be paying closer attention to dimensioning of the part. That it's very small parts that we were working with, so being able to pay closer attention to dimensioning and how that interacted with CATIA and how to improve those dimensionings in CATIA for a cleaner rendering would definitely be recommended. Another method for creating a lot of closer connections and a lot of more parts that were better able to connect to and build with other parts would have been rendering parts built off of other part dimensions. So basically including parts already in your part body and then using those dimensions available from a separate body to create your own body that you're trying to build. And then lastly, I would definitely recommend that we would have improved our smoothing of surfaces or being able to better render our curved elements. We struggled a lot with being able to create some of those curve definitions and all of the stronger curve definitions required for making a more smoother, complete finish. And that would be one of those things that would be recommended for future use.